I'm here at the McMaster University event with Team 1241 THEORY6 event finalists now, and they're going to show off some mechanisms on their robot. Okay, Dion, can you explain the path of the coral through your robot?
Yeah, of course. So starting with our funnel, which feeds from the human player station, we have it actually like a latch mechanism that moves up and down. So at the start of each game, it's within frame comparator, but under here, you can actually see that this string will attach to a Velcro back here, which will spin, detach from the Velcro, and lift it back up, which just gives us more range for our feeding. From there, the coral enters into the funnel, and then we have roller systems in place to make sure it's touch and go, so we don't have to wait and increase our cycle times. So there's top rollers and side rollers, ensuring that any angle that the coral passes through, it's gonna funnel back into our end effector, which is our next system. So
you were explaining how you have that flap at the front of your chute. Can you drive into the feeder station then with a coral on the floor?
With the coral on the floor?
Like if there was a coral in front of you, can you?
So it offers us enough range, so even if a coral is back there, we're still able to feed properly.
Nice, okay. I've noticed a lot of teams get stuck on that.
Yeah, exactly. So we wanted to make sure we had as much range as possible.
Cool.
So moving on from there, we actually have two systems that work with our coral. We have our elevator and our end effector. If you actually come over here, you can see our elevator isn't straight. She's tilted at 10 degrees, and we made this just to allow us to bump up right next to the reef and still manage to reach all 4 levels of coral without having to move any other system. So it's not as if we have an elevator that goes up and another system to reach L4. Because of the angle, we are able to clear all levels, reach L4, and in combination with our our end effector, we're able to score on each level. If you look closer at our elevator, you can see inside we are a continuous elevator, so we can control the positions, but we also have inside belts, inside belts, which we actually reference off of high tide. And with this, we just offer a lot of support within our elevator, so we don't have to come out and only have support on one system with the pulleys. So of course our elevator, and from there, the coral moves from our funnel into our end effector, which works with our elevator. So our end effector is, what I really like about it is that it's actually a dual system. So not only does it intake coral, but it can also intake algae off the reef. So again, coral comes through here, just focusing on coral for now. It comes through our rollers over here. And then here we have our pivot. So actually we'll show you through a process of going from one to the other. Are we ready? Okay, feed.
It's pretty fast.
Yeah. And then we can actually go to L1, L2, L3, and L4. And let's come back down, or you can eject from here, or you want to come down. And we can eject. So again, you can go on all 4 levels, and it's very accurate scoring.
So I noticed for level 4, you actually flip your end effector upside down.
Yeah.
So is that then a different button to eject when you're placing on L4, or does the robot know because which level it is?
I think that's a better question.
Yeah. So the robot knows based on the elevator's position. So if it's above a certain cutoff, we could eject backwards, and if it's not, then we just eject forwards for
Nice.
L3.
Awesome, cool, thanks.
And going on back to what I said earlier, this also works as a algae intake. So if you see the shape of the intake, our mouth gets wider near the end, which allows for enough pinch for the algae to be sucked in. With the overall system, it can intake from L2, L3, and then it can score both in the processor and in the net. So we can't show net sequence. What's really cool about this end effector is we actually have carbon fiber plates.
Nice.
I know a lot of teams have had, including us, have had issues with weight. So we wanted to make sure we were decreasing weight while still keeping a bunch of rigidity, since this is our main mechanism. And yeah, so all of these systems, they work together to create a robot that's, as you can see from this competition, really fast at scoring coral and algae. I guess I'll hand it over to Irvin to talk more on the control side.
Sick. So when talking about autos, we try to do the shortest path possible or to optimize our cycle time. This has allowed us to make 4 different L4 autos, which we use continuously throughout the entire match. And on top of that, we use Path Planner. So with Path Planner, we first do a small path from the reef to the feeder. And then when we're going back from the feeder to the reef, we make a path. However, we then take over with post control. We're using our vision. And the reason we do that is because then we don't have to rely on odometry fully, and we can converge both our vision and our odometry to rely for the best and most accurate results. The reason this transition is so smooth is because we use the ending velocities given from the path, and we then calculate the velocity the PID needs to travel on in order to maximize the transition and to reduce cycle times.
Okay, so you guys made a lot of changes to your vision from Newmarket to Niagara. Do you want to walk me through that?
Sure. So I feel like a good part to start with is that we have two lamp lights, as you can see over here, both angled downwards. The reason they're angled in this position is to maximize our field of view, as we have two of them on either side. In Newmarket, they weren't angled and they were straight because we're using an angle offset technique, and we realized it was quite slow because it took 3 steps to do. So in order to optimize that, we just post estimation, as many other teams have. And from Niagara to McMaster, one more big change, where we calculate the velocity the robot was going at. You get an X and Y vector, and based on the direction it's going, you either pick one of the vectors to maximize a smooth transition.
Okay, so can you walk me through the different automations you have on your robot?
Sure. So in terms of Coral, we combine our drive post command and also our moving elevator and wrist at the same time. The reason we do this is to take some stress off drive team. So all I have to do is just press one button and it goes to the appropriate branch. And on top of that, when we're talking about algae, we have one button to grab the algae, and the same button shoots algae. We do this check based off the static grid of the projector. If it's past the cutoff, we know we have an algae, so we shoot it. And if it's not, then we grab it based off the nearest algae post.
Okay, and this has been 1241 and the robot Haku. Thank you for watching.